Thank you. Yeah, thank you, Adi, for the introduction. Hello, everyone. I'm Jun. It's a great pleasure to be here today to talk about our project, efficient incremental processing using the Maestro and the Iceberg. I'm the tech lead of the data platform at Netflix, doing mainly in the job and workflow orchestration area work. And so hope you enjoying the ice cream bar. And as this is the last talk, I hope the talk can bring many values and fun to you too. Okay. Here's the outline of the talk. I will first give a brief introduction of the problem space, and then I will give a overview of the architectural design. After that, I will show some use cases and examples. Finally, summarize the talk with the key takeaways and future works. So, introduction. Let's get started by looking at the landscape of the data insights at Netflix. Just quick survey. Can you raise your hand if you are a Netflix subscriber? Okay, great. Really glad to see we have many audiences subscribing to Netflix. Thank you. Enjoying the show at Netflix. As you might experience while navigating at Netflix.com, the personalized show recommendation results is quite good. It kind of sometimes, not always, but many times give you the shows that you are interested in, right? Those are powered by the data insights based on multiple data pipelines and also machine learning workflows. And as Netflix is a data-driven company, many decisions at Netflix are entirely driven by the data insights. Data practitioners like a data engineer, data scientist, machine learning engineer, software engineer, even non-engineer like a data producer, they all run their data pipelines to get insights they need. They can be like just the color used in the landing page when you visit Netflix.com, or it can be that, as I mentioned, the personalized recommendation, or the content producer may decide if they should renew the lease or like terminate the next season of the show based on data insights. Also, like we can even we also like scan data to get like a security issue or anything. So data are used widely. So okay, yeah. Let's go next one. So as the business continues to expand to new areas, like from streaming to the games, to the ads, to the lives, right? You may watch the recent live events on past Friday. So the demand for the data continues to grow. And those new initiatives also bring lots of new requirements. For example, like a security requirement, privacy requirement, or latency requirements. And they are all bring a wide variety of use cases to the platform as well. So while users working with the data practitioners usually face three common problems: data accuracy, data freshness, and cost efficiency. With a huge amount of data, right? The data accuracy is critically important. Business decisions have to be made based on the high quality data. Also, with that amount of data, if there are some issues, you have to correct data, then it might be expensive and also time consuming as you have to backfill a lot of data. Data freshness is also very important. Users need to process large data sets quickly to enable fast business decisions. Cost efficiency is always important as we run the business. Netflix spends $150 million per year just on the compute and the storage. Also, I would like to call out that these three problems are general and common problems. No matter how big or small your data is, it might be more impactful if the data size is large, right? It costs a lot. But if we can solve them, this will be a game changer and enable lots of new patterns and also allows us to rethink about the batch ETL in analytics domain. There are lots of challenges to solve those problems. One of the important one is the layering data. This graph shows a visual example. For instance, last night, 10 10:20 p.m. I watch Netflix, right? I open my app. Then my phone's battery was dead. Then the event generated at that time at device at 10:20 p.m. won't be able to send it to the server, so it buffered at my device, right? Then I put my iPhone to the charger, and then I went to sleep. This morning I got up at 8:20. Then I open my phone and start Netflix app. Then the events at 8:20 a.m. plus the events generated last night, both sent to the Netflix server, got processed. So those events generated last night got processed with a few hours of multiple hours of delay, and then that's caused trouble. So the key is that the event time matters a lot to the business, not the processing time. So many times the streaming or ingestion pipeline use the processing time so they can quickly ingest data and append data to the staging table, which is partitioned by the processing time. This can greatly simplify the streaming pipeline, which is wonderful. And then it leaves the later batch analytics pipeline to handle the later in data. As the data lands late, right? So the data processed a few hours ago or in the past becomes incomplete, which then causes the data accuracy issue. We can fix that by reprocessing the data, but given that amount of data, the data might be expensive or time consuming. Also, while we deal with those kind of large data sets, we usually have to carefully design the partition schema to fit the business needs, right? And then the later in data might block the downstream pipelines to start because those pipelines would like to start to process data only when the data is complete as much as possible. So that will reduce the data freshness as well. So to assist data practitioners and Netflix to work with data, solve those problems, or develop any solutions, we developed this big data analytics platform as a high-level abstraction to offer the best user experience and high-level abstractions for users to interact with those engines, computer engines. So users use our Maestro workflow illustrator, which abstract lots of the complexity from users. They don't need to deal with the Spark directly. They can easily write their jobs and then use the engine they like to process their data. Eventually, data is saved to the Iceberg table. So we observe the users in our platform usually follow those two common patterns to deal with the later in data. First is called look-back window. So in that scenario, the workflow owner or the job owner usually have a lot of business domain knowledge, so they kind of can tell how long they should look back, right? If the data is older than that window, likely there's not much business value there, so they can discard. So then they can, for example, always reprocess the past 3 days of data every day to insert overwrites to target table every day to bring back the data accuracy after 3 days. Another approach is that we can just ignore the later in data. That sometimes works, especially the business decision may have to be made, right, at real time or at that moment. Then if data is not there, then you cannot make it. We have to make a decision. Then we make a decision. So later in data doesn't matter. But then we got freshness, we got cost efficiency, but we lose the data accuracy. Another well-known pattern called incremental processing can address those problems. Incremental processing is just an approach that to process data, but only the new or changed data. Here we focus on the analytical use cases. So to support that, we have to solve two problems. Right? One is how we can capture the change. Secondly, how we can track the states. In this talk, I'm going to show how we can use the Iceberg plus the Maestro together to efficiently support the change capturing and also give user very great experience to integrate with their pipelines. So let's talk about Iceberg first. Have you heard about Iceberg? Can you raise your hand? Oh, some. Okay, great. I still give a very quick brief. So this is a high-performance table format for huge analytics tables. And this project started about 8 years ago at Netflix. It now becomes the top Apache project and one of the most popular open table formats. So it brings a lot of great features. I list some of here. And it simplifies a lot for the data management. For our project, we leverage the Iceberg metadata layer. It provides lots of information to help us build a mechanism to be able to catch the change without actually reading the user data at all. I'm going to talk about it later. Let's go over some basic Iceberg table concept first. So Iceberg table are saved in the catalog. This catalog can be pluggable like a Hive catalog or Glue catalog or like a JDBC or REST catalog. At Netflix, we have our own internal catalog service as well. Then the tables will save the metadata in the metadata file, which has a list of manifest files, which map to the snapshots. Then those manifest files are just files save the lots of additional information related to the data files. It also keeps the reference of data files as well. And then Iceberg will produce the partition value by taking a column value and optionally transform it. Then the Iceberg tracks this kind of relationship. The table partitioning scheme data design is purely based on these relationships, so no longer depends on the table physical layout. That's a very important property that we can leverage to build that efficient incremental change capture feature. So data practitioners at Netflix use Iceberg, create like more than 1 million tables there, and develop hundreds of thousands of workflows to kind of read or write or transform the data of those tables. We then need orchestrating those workflows, which that's why we invented Maestro. Maestro is a horizontal scalable workflow orchestrator that's manages the large-scale data and machine learning workflows. It manages the end-to-end whole life cycle, so give user kind of a serverless experience. They just like own their business code, and then they ship the code to the platform. So it offers multiple reusable patterns like for each, conditional branching, and sub-workflow, and so on. So our users also build additional patterns using those usable patterns. It is also designed to expansion and integration with others, like Metaflow. You might hear that talk yesterday about Metaflow. Metaflow integrate with Maestro. Then Iceberg. In this talk, we are going to talk about that. So we initiated the Maestro project about 4 years ago. The decision to build our own workflow orchestrator instead of using those popular ones like Airflow is just because that the challenges that Netflix were facing, for example, like scalability. We need like a horizontal scalable workflow orchestrator, and also like a usability and extendability. We had the alpha release in like 2021. Later, we got in 2022 we have the beta release, and then later 2022 we got a GA internally. Then the team spent like 1 year to move hundreds of thousands of workflows from the old system to the Maestro. It's a fully managed migration. Users don't actually make any line of code change. After that, this summer, this year, we make the Maestro code to be publicly available, so you can try it out after this talk. I also put some QR code here. If you like, you can visit there. Those are our blog posts. Describing with more details about the Maestro and also the open source project. Okay. So I would like to show these simple examples just like to give you some sense like how users interact with Maestro or write their workflows at Netflix. So this is like kind of configuration like a definition, but users define this, and then they also can include some business logic there. So the first section, like a description section, that the user can put some information, even like some on-call instruction there. This supports markdown syntax, and then when there's alerts or there's something wrong with this workflow, when we send email, we can include this description in the email body as well. And then user can say, I want to trigger it to run daily. So we support like a cron trigger and also singular trigger as well. For example, if the upstream table is ready, then please run this workflow kind of singular trigger supports. And then here you see in the workflow, users can define parameters. Parameter can reference another parameter and doing the runtime evaluation. Here, the parameter of my query include the SQL query trying to do something. Then user can define, oh, I want to run this query in the Spark. Okay, then they just like simply put this configuration there. They don't need to worry about like which cluster they need to route to, or like what's the memory or settings they need to use. They can always let the platform to decide that. So they just need to pass us a query. Then once they have this workflow definition defined, when they save it, they can use our CI tool, trying to push it and then run it. So during the development, right, the query may not be perfect, or they may need like multiple iterations. You can just simply run the query, use like cycle 1 or something first. Until you are satisfied with your results, you can like plug in the production query. And then user can also use the UI to take a look what's wrong or what happens. So Maestro provides a kind of workflow platform for everyone, serving thousands of internal Netflix users, including engineers and non-engineers. So it offers multiple interfaces and also flexible integration and dynamic workflow engine and this extensible execution supports. With all these features, Netflix become Maestro has become very successful at Netflix as the data and the machine learning workflow orchestrators. Thousands of our users use that, develop hundreds of thousands of workflows there. It runs like 500,000 jobs, and sometimes in some like busy days, it even run like 2 million jobs per day. Yeah, I put a QR code here. You may learn more from this blog post. Again, we would like to provide a clean and easy to adopt solution for users to be able to do the efficient incremental processing with data accuracy, freshness, and cost efficiency. Okay. Now let's start the fun part, architectural design. So there are two major goals of this design. Firstly, we need to efficiently capture the change. This is important not only because like efficiency, but also because like the lots of times, right, we cannot access user data because of security requirement or the privacy requirement. So in those cases, then this kind of requirement, efficiently capture change without reading user data, become really important. Fortunately, that Iceberg provide all these supports in their metadata layer, help us to achieve this. Second is to get the best user experiences. You can imagine that many of users develop that amount of the workflows in our platform, right? We cannot break them, or we cannot ask them to make changes or significantly. So we would like to offer the best user experience. The key is that to decouple the change capturing from the user business logic. So in that way, the implementation or the support of the incremental processing can be engine or language agnostic. In that case, the user can use whatever language they like or computer engine they like to implement their business logic and leave the incremental processing to be handled by the platform. So Maestro provide all the support to kind of develop this kind of interface. Okay, now first let's see how we can efficiently capture the change. As I mentioned, the Iceberg metadata provide lots of useful information. The snapshots contains information about like how many change rows or added data files, and then the metadata file per data file gives us the information about like the reference to the data file and also the upper and lower bound of the change of a given column from that data file and so on. All those information can help us build a very efficient way to capture the change or capture even the range of the specific column. then they only need to we only need to access those metadata and get a reference of data file, and then use that. We can build a mechanism to track the changes, so then we can capture those changes. It's a zero data copy, and we don't touch user data, so the change captured and will be included in a table, which then becomes an interface to hand to our users to consume. So they can, this table is like the same table as the original table with the same schemas, like security access, everything. But the only difference is that this table only contains the change data. And then the table name can be a parameter passed to the user job, then user just consume everything from this table, then they get the change data. Next, I will use an example to show how this approach works. So here, I have this simple table called DB1 table 1, right, at work clock time T1. As I mentioned, that there's only one single snapshot there, and then it has like 2 manifest files, which has 5 data files there. Those 5 data files actually maps to 2 partitions. Those partitions are virtual, as I mentioned, right? So the data files are immutable in the storage, and then at the query time, you got those virtual kind of table partition. Okay. So yeah, I highlight here, and then next, you see here, I got at the T2, I got a new snapshot as 1, where here it has 3 new data files append to this table, and they somehow have the later in data, so they goes to the partition P0 and P1 and P2. P2 is a new partition, but then those data goes to P0 and P1. But you will want to process, right, using like a traditional way like high, right? You want to process all the data. We have to select data from like P0, P1, P2, everything, which means that we actually reprocess those 5 data files again. It's not efficient. Yeah, thinking about that, if this is like 40 days or like something, huge amount of data. Then instead, using the Iceberg features, we can create a kind of table called like IBP table 1 that has the same schema as the original Iceberg table. It's indeed an Iceberg table. And then we add a new snapshot, which has a manifest file, but at this moment we don't create or copy those data files to create a new data file. Instead, we can read the snapshot information from the S1 to get a reference of those data files, and then we just simply add reference to the manifest file of the S2 in the new table. In this way, we can actually reference them without copying the data, right? It's 0 data copy, and then when user query, they select start from this table, they will get 3 partition P0, P1, P2 as well. But in this new virtual partitioning, they don't have those old data files at all, which means that they will not reprocess data. Also, after a while, right, the platform is responsible to delete this temporary table while after the ETL finishes. There are some other alternatives to achieve the similar goal, like to enable this incremental processing using the Iceberg, like Iceberg with Spring, with Spectra streaming, and so on. We didn't go with those approach, mainly just because they are coupled with engine tightly. So this is not only like requires user to interact with those libraries using their API or some implementation client and add into their business logic, also require users sometimes have to rewrite their code. Well, for example, if they use Trino, right? If they use other engines, they have to use the engine that is supporting incremental processing. But I think underlying implementation, all those implementations are kind of similar, which I show some code here. Basically, we kind of load the table and then use the Iceberg APIs, get the snapshots between the 2 snapshots ID, and with some filters say we only care the append partition information, and then we create an empty table with the same schema as the original one. Then we scan through the snapshots table, add data files one by one to this new ICDC table. After that, we commit it right now. So of course, this code is simple and it's not like for production, but it demonstrates the idea clearly. So you might consider a similar approach in your solution if applicable. So this new capability enables many patterns. Here are 3 emerging ones that we observed or discovered at Netflix. So I will talk them one by one. Firstly, we are going to talk about incrementally processed change data and directly appended to the target table. So as we have shown, the change data will include reference to the real data file, right? The change, this table have the reference to the real data files. And then in the ETL workflows, they can simply just consume the ICG table, select star from it, and then they can get the those change data file and then append to the target table. It does not need to reprocess the whole partition of P0, P1, P2, and it will bring a lot of savings. And also in the future, this might be supported by those SQL extension or something, right? You can select star between these 2 snapshots or something. We actually are working on this. Okay. A second pattern is that we can use this captured change data as a row-level filters. So in many times, right, especially in the analytics domain, the change data itself does not actually give us the full data sets to process. Just for example, if I want to get the watch time for all the Netflix users, right? In that case, is the change data from the past time window only tell me the users that recently watched Netflix, right? But it does not give me total time. However, this change data itself, we just take a look at the change data and select a unique user ID from it, right? We are going to get a small set of the user ID. Those users at least watch Netflix in that window. With that, while we're doing the processing, we can use that as a filter. We can join the original table on this table by this kind of user IDs that we find. We can quickly prompt the data sets to process, to transform, to be able to get the sum easily. Here I show example. So by looking at the change data, we found that the circle and diamond, right, actually are the keys that are in the change data. And then ETL can load the table, quickly filter and find those kind of diamond and the circle data points, and then doing the aggregation and save to the overwrites the target table. So in this example, I use a simple sum. So it's you might think about some other incremental way to doing the sum, but note that this business logic can be anything, right? It can be very complicated. You may not be able to do that kind of incremental summation or something. So this is just for demo. Okay, the third pattern is use the actually the capture change range parameter. That's a little bit different from the change data capture. We even don't need to create a table. Instead, we just need to get the upper and lower bound of some specific change columns from the source tables actually. This is very common, especially if you are going to join multiple tables, right? That is a common pattern in the batch world. Where you join 2 tables, then you have to find like those common range that you need to select all the data between them to be able to run the join or run any complicated processing. In that case, we can read the Iceberg metadata to quickly get the range like mean or max of the from all the tables for a given column, and then we can tell like, oh, this is mean. Okay, the mean is P1 and max is P2, and then I can load the table, the partition P1, P2, and the partition P1, P2 into ETL workflow, and then doing the processing there. So this pattern is very useful in the analytics batch workflows because it's very common to join many tables, not just 2. Are we done? No, we are not done yet. Onboarding cost is another major concern. Thousands of our users develop hundreds of thousands of workflows in the Maestro, and then we cannot break those workflows or users or ask thousands of users to rewrite that pipeline. And also many times, even like a user pipeline is not independent or completely independent. So many times they are dependent with each other, so you have multi-stage pipelines. In those cases, they might have some stage is enabling incremental processing, but some other stage are not incremental processing. So we have to like support a mix of those kind of pipelines as well. And then those extra costs like development, operational maintenance might completely offset the benefit of the incremental processing. So some of the feedback we heard from users is that I don't have bandwidth to rewrite, right? So can it just magically work with little changes? The answer is yes. So to address those concerns, we provide other interfaces in addition to table interface. There are two new Maestro step types. One is called IP capture step type, which encapsulates all the business logic from the platform to be able to capture the change of the table. And then the IP commit step, which can commit checkpoint based on the IP capture step information. So with this design, user workflows can simply onboard to the Maestro IPS support by just adding one job of IP capture from and one job of IP complete after their user jobs. So as I mentioned, like we are going to have the ICD table, right, include all the changes, and then that table name will be passed as a parameter to the user jobs. So that's a great interface for user to be able to simply just consume that table. Most of user business logic will be exactly the same. They don't need to worry about like how to capture the change at all. In case we maintain or upgrade or fix bugs in our change capturing logic, user won't get impacted. They just need to rerun their job, everything will work. They don't need to add any library dependency to kind of get incremental processing support. And also multi-stage pipelines can work as well, because this is just like a typical standardized Maestro workflow. All the workflows can work using the Maestro features. With those interfaces, all existing workflows can work together seamlessly, and so user can use the best way to implement their business logic, can use the engine they like. And also Maestro step is kind of configurable, as I just showed you, with a very low code solution there too. I would show a kind of a complicated example here, just to demonstrate how powerful and simple that approach is. So here's a complicated workflow example that our user developed trying to auto-remediate the issues. So many times, like in your ETL pipeline, right, it may fail because of some kind of small problems here there, and then the on-call will wake up and then rerun some script to fix a data problem or something, and then just kick off the restart again. And then in this auto-remediation approach, user doing the similar thing in this workflow that either cause this typical ETL pipeline plus auditing process, and then they can tell Maestro, okay, if this workflow failed, please don't fail the workflow and page me. Please just ignore that first, and then run a recovery job. So this check status job will see, oh, you've actually the workflow fails or not. You failed. It goes to this recovery step, run the recovery job, and then run this workflow again to see if it succeeds. If not, then page a user. So this is how user define that using the Maestro. So they can go define this workflow, right, with this special flag saying ignore failure. Then they define the DAG information, which I mentioned, like if else condition here, trying to route the workflow to different paths based on the status of that workflow job. To enable incremental processing for this complicated pattern, it's very simple. You just need the IP capture step at the beginning and the IP commit step at the end. That's it. They don't need to actually modify lots of their code. And then you can see here is the new pipeline. So this is a workflow which points to the workflow that I just showed. It's an auto remediation pipeline, and then it passes the source table, which is now become the ICD table name to the sub workflow, where it also can pass a query as well. And then it adds this IP capture step, trying to capture changes. It says it's ICDC mode, and then the table is a membership table, and then only care the appended only in snapshots. Then in the commit step, user just need to tell us what's the step ID of the IP capture. That's it. So IPS can efficiently capture the incremental change and handle the later-in data. With those clean interfaces, the solution is compatible with the existing user experience with really low onboarding cost, as I just showed. Next, let's walk over a few user cases and examples together. So this is a two-stage ETL pipeline with 2 Maestro workflows and 3 tables. And so this is a playback table which saves the ingested events from the streaming pipeline. And then the workflow owner decides like I have to take a look back at like 14 days, 2 weeks of data, because there's a lot of events come late. And then in their daily pipeline, they kind of aggregate this table and then save it to a target table by changing the partition key from the processing to the event time. And then they have to do this every day and rewrite the past 14 days of data. This pipeline can take quite a while, so they have to run daily, they cannot run hourly. And then for this table, consumers, we may have like multiple hundreds of workflows consumed from this table. They build kind of aggregation pipelines to power their business use cases. And then here in this case is this doing the daily aggregation also have to consume the data from the past 14 days as well. So you can see it's time consuming, plus that is also fragile and many times if there's a traffic pattern change, right? So suddenly there's a huge events land or there's like a business logic change, user have to adjust this lookback window, which then will affect all the downstream workflows and everyone as well. That's not a great pattern. And then let's see how we can make that to be IPS enabled. So here's the one that using the pattern 1, you can see that we can easily just like have a ICDs table to hold the change data, and then let this pipeline to consume from ICDs table instead of from the original table. Then we can easily merge into the target table. And also, because this runs so fast, we can do this hourly instead of daily. And this shows the some kind of changes in the user job, writer job. I just use the SQL as like a demonstration. There's also Scala or some other logic. You can see that instead of insert overrides, we can use merging two, and then just change the from table from the ICDs table, and then add the dedupe logic. Also, you can use insert into if you like, or there is a dedupe logic or other workflows running trying to dedupe the data. Okay, for the stage 2, we use the pattern 2, where we can have the ICD table hold the change data, then join with the IPS table, join with the original table, and then doing this aggregation again and merging to the target table. Same thing, it can run super fast, and then we can update the workflows cadence from daily to hourly as well. And this shows the change in SQL. So basically, same thing, insert into override, merge into, and then we join with the ICD table on those aggregation group by keys. Then we add the dedupe logic as well. Okay, so after changing this two-stage pipeline from the original way to this new IPS enabled approach, we see a huge savings. It's you see that because lookback window is about 14 days, right? And also the later in data is sparse, right? It's not always has lots of later in data. So actually the cost of the new pipeline is less or like only like 10% of original pipeline. Also, it improved the data freshness as we can now run hourly. Yeah. So the next example shows the multi-table cases using the pattern 3, where we have like 3 staging tables, row tables, which have the events from stream pipeline, and the first one, the last one has like a later in data, and the middle one does not. So middle one can be a normal pipeline, and this first and the third pipeline will be the one with the IPS enabled. Then they produce this hourly table, 1, 2, 3, and then this final pipeline will based on the range captured, right? Here is 3, min is 3, and max is min or max is 6. So I'm going to load the data from all three tables from partition 3 to 6, our 6 to 3 to 6 together, and then doing the complicated join operations to produce data to the target table. Okay. Yeah, I hope this example demonstrates how simple and powerful it is for users working with Maestro using the like IPS. Now, let's do a quick recap. So IPS enables new patterns, and also let us rethink about ETL, batch ETL, which is sometimes kind of considered to be replaced by the streaming pipeline, which also have some other troubles as well. And then, so actually, the batch ETL is still very popular and widely used, especially in the analytics domain. With this IPS support, we can power the ETL, batch ETL, to have the data accuracy, data freshness, and the cost efficiency, all of this. That can fill lots of gaps and enable lots of use cases, even sometimes that we may not need to move to the streaming and can stay with the batch. So in the talk, we show like how we can use the Iceberg metadata to be able to efficiently capture change. And then we also show the power of the decoupling that either can help to address concerns differently and then let the user have minimum changes. Also, with the clean interface that Maestro provides, we provide a great user experience, and also with minimum effort, user can adopt to this new approach. Also, hope you can leverage some of those patterns that we discovered in your work if applicable. So what's next? So we are going to move some of the implementation from our own side to the Iceberg like SQL extension to be able to create a view instead of a table to reduce the maintenance costs, so we don't need to delete a table. And also we add support. We are going to add support for other types of snapshots beyond just append. And also we are working with Iceberg community to add a cookbook to show how doing the change capturing. And last but not least, we are working on the auto cascading data backfill features using the IPS. So lastly, I would like to acknowledge the team, the Netflix team for the great teamwork. And this concludes my presentation. Thank you.
All right, Jun, thank you so much for a great presentation. If anyone has questions, this is a good time to raise your hand. Jun will also be there later on if you want to take questions, and he can take questions in private as well.
Thanks for the talk, Jun. So I have a question regarding the join operation that you mentioned for incremental processing. So if let's say I'm doing like a 7 day or 14 days of join, right? Even for the incremental part, you will still need to load the data on left side and right hand side, both for 14 days, right? Because the incremental data might be joining with the historical data in the past. So I'm trying to understand, how would you be able to achieve like 10x of the cost reduction in that case?
Got it, yeah, that's a great one. So that reduction is based on the fact that if you guesstimate the range you need to do the join, right? It may not accurate, or many times you have to kind of be conservative to handle the worst scenario, so you actually have a really long window. Then you kind of then you join that. So, but you are right that the cost efficiency we got here is mainly for the pattern 1 and 2, but not for the capture range cases. In the capture range cases, it's more like we can achieve the optimal data accuracy as we know exactly what's the change. But the gain, the cost efficiency gain from there may not be that huge, like 10x.
Thank you again, Jun, for a great presentation. Please give Jun a big round of applause. Perfect.